Great. Now here is my favorite topic, solid principles. If you have more than 4 or 5 years of experience in .NET more than, then this topic is for you. And here are the 7 questions from it. We will start from the importance of solid principles. Then we will cover all solid principles SRP, OCP, LSP, ISP and DIP one by one. Although DRY is not a solid principle, but that I will also cover in this section. The approximate duration of all these questions is just around 20 minutes. What are solid principles? What is the difference between solid principles and design patterns? First of all, what is a principle in general? A principle is a general or basic truth that must be followed and must not be violated, right? Similarly, solid principles are a set of principles which must be followed to develop flexible, maintainable and scalable software system. They are not optional. They must be followed in every application, okay? Whereas design patterns are concrete and solve a particular kind of problems in softwares, okay? For example, singleton pattern solves one problem of preventing multiple objects creation in the class, right? But maybe that problem does not exist in your software, so you do not need to implement singleton pattern at all, right? Therefore, design patterns are optional to implement and required to solve a particular kind of problem. Another unrelated example is like honesty, integrity, truth, all are the must principles of life which a human must follow. But like career paths like finance, education, technology, all are good careers. But you can choose only one to make a good career, right? Similarly, a great software can be made by using just one or two design patterns. But violating any solid principle is not good at all for softwares. In a way, solid principles are more important than design patterns. Here are the 5 fixed solid principles, and here is the list of some important design patterns, not all but yes some. The next difference is solid principles are not concrete, they are abstract, meaning for example, to achieve a single responsibility principle, there is no concrete or fixed solution. You can achieve it by using various ways in your application. Whereas design patterns are concrete and solve a particular kind of problem in a particular way, right? So for example, to implement factory pattern, there is a specific and fixed way to do it. So now the differences are clear, right? What is single responsibility principle? This is the first principle. Single responsibility principle SRP states that a class should have only one responsibility, or a class should have only one reason to change. Let's say you have a class called employee. This class has a method calculate salary that calculates the salary employee salary. Now the get department method to get the department of the employee, okay? And another method save that saves the employee to the database. Now to save, add or delete employee to the database is not the responsibility of the employee. So it is like an extra responsibility, right? Therefore this violates the SRP because this class has extra responsibilities and one class must have same kind of responsibilities. Now to apply the SRP, we can separate the responsibility into 2 separate classes like this. And here is the code. In this example, we have separated the responsibilities based on the core employee responsibilities, and the extra responsibilities which needs direct database interaction will be there in the employee repository class, okay? If you are aware about repositories and the services classes, then they are the perfect example of single responsibility principle which you can give. Another good example is if you have one invoice class, suppose, then add invoice and delete invoice can be the part of it, but sending invoice mail and error logging are extra responsibilities. So create separate classes for them to follow SRP there. The advantage of SRP is when a class have only one responsibility, it becomes easier to change and test. So if a class has multiple responsibilities, changing one responsibility may impact others also, and more testing efforts will be required then, right? So this is the advantage of SRP. Great, I think now you know SRP. What is open closed principle? This is the second principle of solid principles. Open closed principle OCP states that a software entities like classes, modules should be open for extension but closed for modification. In other words, in order to add some functionality in a class, do not modify the class, okay, but extend it, okay. For example, suppose we have a bank account class which has the properties name, address and balance in your account. And here you added one method also which is used to calculate interest based on your account type. Now if the account type is saving, then the interest is 3% and therefore interest amount will be balance multiplied by 0.3, okay. Similarly, if the account interest will be multiplied by 0.5 in another case. But suppose tomorrow we get a new account type and that is current account, and for that the interest is 7%, then how you will add this thing? So what you will do, you will add one more else if condition here in the middle, right? So basically inserting one more else if will violate the open close principle because you are modifying the class rather than extending it. Now the question is how to extend this and how to follow OCP. The first step is to follow OCP, you must follow SRP first because SRP is the prerequisite of OCP. And to follow SRP, you should only put the account level methods and properties in the account class like this, okay. Then by using the SRP, you should only put the account, So then by using interface, you should create one interface I account with declared method calculate interest, which accept account class object as a parameter, okay. Then implement the interface for separate class saving account and other account like this. And because you implemented the interface, you must have to define the calculate interest method here inside it, okay. And you can put the same logic of calculate interest here. See, we have implemented SRP and our structure can implement OCP easily now. Now if you want to add the new account type, then you do not need to have to modify any class, right? Like this, you can add one new class current account. And same way it can be implemented I account interface with 7% interest. See, OCP implemented so easily if you will first implement SRP properly. The benefit is simple testing is required to test individual classes. But if you will keep on adding and modifying one class again and again, keep on adding it, then even for the smallest modification, you have to test the whole class again, right? That might not be an issue for the small projects, but yes, in big projects, more testing needs a lot of efforts. Great, I think now you know one more solid principle, and that is OCP. What is Liskov substitution principle? For this principle, I will first explain the normal definition, and at the end, I will share one very easy statement about LSP. Let's see the normal definition first and understand with the help of the code. The Liskov substitution principle LSP states that an object of a child class must be able to replace an object of the parent class without breaking the application. Remember, child class, subclass and derived class are same things, and parent class, superclass and base class are same things, okay. Now let's see the example code. First we will see how to follow the Liskov substitution principle, and then we will see how we can violate the LSP, okay. Suppose you have a parent class employee which have two virtual methods, calculate salary and calculate bonus, like this. For simplicity, I am not calculating here anything but just returning 1 lakh as salary and 10,000 as bonus, okay. Now we have one class permanent employee which is derived from the employee class. This class override the calculate salary method of the base class and set a new salary, and this class will automatically get the calculate bonus method from the base class, right? Because we are not overriding it here. And as the rule of the inheritance, base class methods will be automatically available for the derived classes. Simple, right? Now we have one more class, contractual employee class, which is again derived from the employee base class. Here we will again override the calculate salary method of the base class like this. But this contractual employee class does not supposed to have this calculate base bonus method of the base class, because bonus is not applicable for contractual employees. Okay, therefore here we have to override the calculates bonus method and throw the error like this. Why we are throwing the error here? Because if we do not override the calculate bonus method and write no code here, then by default the contractual employee will automatically get the calculate bonus method of the employee class, parent class, like the permanent employee class inherited it, right? And if anyone in future will create the object of the contractual employee class, then that object will be able to call calculate bonus class then, right? Which we do not want, because as per the rule of the contractual employee class, that should not be able to call bonuses, right? So to stop that, we have to override this method here and we have to throw the error. Now if someone will create the object of this contractual employee class and call this calculate bonus method, then they will get this error, right? Now let's first follow the LSP and then we will violate the LSP. First, inside the main method, we will create the object of the base employee class like this, and we will also create the object of the derived classes also here. Now first, we will call the methods from the base class objects like this. See, no problem, and 1,10,000 will be the output as salary and bonus, okay? Because that we got from the base class methods, right? Now listen carefully and read the definition again. The LSP states that an object of a child class must be able to replace the object of the parent class. Okay, so as per the definition, we will replace the parent class object employee with the permanent employee child class object P employee like this to call the exact same methods. And see, your application will not break. These methods will completely work fine, right? And the output will be like 2 lakhs and 10,000 this time. That means here we are following the LSP for the permanent employee class case, right? Because here object of a child class is able to replace the object of the parent class without breaking the application. Now we will see how to violate LSP, when we will violate LSP. Now we will replace the parent class object employee with the contractual employee child class object C employee to call again the same exact methods like this, okay? Here the first call of calculate salary will work fine, right? But the second call of calculate bonus will break the application and this exception will come. So here object of the child class is not able to replace the object of the parent class because the application breaks, and therefore for this particular example where employee is the base class and contractual employee is the child class, we are not following LSP. Now might be you will say the error is expected, right? Because yes, we are throwing the error inside the calculate bonus method of the contractual employee class here. Yes, this is expected. But we were forced to throw the error here. That is because we have to do, because otherwise I already explained you like how contractual employee class will automatically inherit this bonus method, right? But we should never design our classes and methods in this way, in such a way where we have to throw the error like this, okay? This thing we should avoid. So when designing base classes and derived classes, then we should make sure that whatever methods we are keeping in the base classes, okay, those methods must be applicable for the derived classes also. Derived class can override the base methods and that is completely fine. But by default, if those methods are not overridden, then all the methods of the base class must be applicable for the derived class. That should be the ideal design approach as per the LSP. Like in our example, all employee class methods are applicable for permanent employee classes, right? All methods. and therefore that they are following LSP. But for contractual employee class case, our design is not good, as we are throwing errors here, and because calculate method, we all know the reason, and that's why we are violating the LSP here. All right, now we can correct the design, like we should to correct this design and to follow LSP for contractual employee also, we should remove this calculate bonus from the employee base class and put it somewhere else, like some other class, some abstract class, interface, some other design we can do, but we should not do like this. Finally, as I said in the beginning, the short statement for LSP, or the in other words, what we can how we can define the LSP is, all the base class methods must be applicable for the derived classes also. All the methods. Okay, I think this is the simpler definition. Great. Now I think you have a good understanding of the LSP, and even in your projects you now know how to implement LSP, right? What is interface segregation principle? Let's see the definition first. The interface segregation principle, ISP, stated that a class should not be forced to implement interfaces that it does not use. Okay, so let me explain with the example. Suppose you have an interface I vehicle which has two methods, drive and fly, declared only. Okay, now you are creating a class flying car which will implement the I vehicle interface method, something like this. Perfect. But suppose tomorrow your manager asks you to create a class for just a normal car. Okay, and then you will write the code something like this. Here this I vehicle interface is creating the problem for you, because fly method is not applicable for car class, but still you have to implement it, right? You have to implement all the methods of the interface, right? So what was the definition? The interface segregation states that class should not be forced to implement interfaces that it does not use. And here we are forcing on car class to implement the I vehicle interface methods, this fly method, and it does not use this, right? So we are violating interface segregation principle here. Now what is the solution then? One solution is, it is better to have multiple smaller interfaces than larger interfaces. For that, we will divide that big interface into a small interface like this, I drive and I fly like this, and then car can inherit I drive interface and implement just the drive method without any problem. And what flying class can implement both I drive and I fly interface and implement both drive and fly method like this. So basically multiple inheritance, you remember, can be done by interfaces, right? Now we are not forcing any interface method on any class, right? So this is interface segregation principle. Segregate your interfaces as small as possible as per the derived class needs. Okay. What is dependency inversion principle? The definition is, the dependency inversion principle, DIP, states that a high level class must not be depend upon a lower level class. Okay, so what is high level, what is lower level? Suppose we have a data access layer class that is responsible for adding a customer to the database. Okay, and however, instead of depending on an abstraction like an iLogger interface, it directly creates a file logger object and call its method log method to write a log message like this. Here data access layer is the high level class and file logger is the lower level class. And you can see data access layer class is tightly coupled with the file logger class and is depend on it, right? But as per the definition, high level class must not be dependent on the lower level class. Therefore, this implementation violates the dependency inversion principle. Okay, the disadvantage of this is, if tomorrow you want to replace this logging technique or behavior in your own application, for example, from file logging to database logging, you want to modify inside the data access layer. Here is the file logger log method. Okay, the method is same, but you have to use a new class. Now the question, so it will be a tight coupling, and you have to replace, like here we have only one data access layer class, but there can be multiple classes like this. And if you want to replace, then you want to replace all over this file logger with this new database logger. Okay, now to resolve that, we have that dependency inversion principle. And if you already know dependency injection, then you remember how to inject the dependency class from the constructor, right? So dependency injection is a design pattern to implement dependency inversion principle. Okay, it's a one of the way to implement dependency inversion principle. Now to implement, first we have to create an iLogger interface that just declare the log method, as well as a file logger class that implements the iLogger interface and provides in its own implementation of the log method here inside. Now in the data access layer, inject iLogger object as a constructor parameter and store it in a private field like this. Then when the add customer method is called, it uses the iLogger object to log a message instead of creating this file logger object directly, right? Now high level, this data access layer is high level, right, is not dependent on low level file logger class. As we are, you can see we are not using anywhere file logger inside this data access layer here. The benefit is, again, tomorrow if you want to replace this file logger with the database logger, then you can easily do it. Just then add a new class database logger, inherit the class from the iLogger, implement the log method as per the new requirement, and remove this file logger class. And then automatically your iLogger, which you injected in the data access layer constructor, will start pointing to the database logger method. Okay, because file logger is gone. Now iLogger is referring to database logger. Now no need to change any code inside this data access layer or inside any other class which is using the iLogger. Okay, because now you are not coding for the classes, you are coding for the interfaces. That's it. Great. Now I think you know dependency inversion principle, right? What is DRY principle? This is not among the solid principle, but yes, this is very important and very simple to know. Okay, so the first point is DRY stands for do not repeat yourself, meaning once you have written one code, try to not repeat it anywhere else. Try to put that code in some method and reuse it again and again. Then second, do not write the same functionality multiple times. This is just the same thing. Third point is instead write code once and then use it at multiple places using inheritance. Now the same thing, but you can use inheritance. For example, you have written one method for 10 classes. Now what you do, for those 10 classes, create a base class and put your method over there in the base class. Okay, then all the derived 10 classes will automatically get it. So getting my point? So you are not repeating that one method at 10 places then. So this is the DRY principle, and this is also very, very important. Here is one topic which is for the more experienced candidates, and that is design patterns. Here is the list of 10 questions on it. To keep it short, I will cover only the basics of design patterns. Otherwise, there are more than 20 to 25 design patterns available, which are like impossible to cover all this in this, even in this complete course. Okay. So, but yes, the most important one, singleton and factory method pattern. So all that are covered. Okay. So the approximate duration of all this question is around 25 minutes, even though I have covered only 3 to 4 very important patterns only. What are design patterns and what problem they solve? Design patterns are reusable solutions for common problems in software design. Suppose you want to implement logging for your application. Okay, now almost every application will have logging in it. So you will try to find the best logging design technique that you will implement it, right? Now this technique, if it is really good, then it will be used by many developers, and then it can be a reusable solution. Now you will get many reusable solutions in Stack Overflow, GitHub, but are they all design patterns? The answer is no. The reusable solutions which solves the problems related to designing of the software, only those are design patterns. For example, while creating an application from scratch, when you are designing the classes, then how the classes will communicate with each other. For that, if there you will use some reusable solution, then that will be a design pattern. What are the types of design patterns? First, we have three categories of the design patterns: creational, structural, and behavioral. Now, under these categories, we have the type of these design patterns, and under the creational category, we have factory, method, builder, abstract factory, and singleton design pattern. Under structural category, we have adapter, decorator, facade, and proxy design pattern. And under the behavioral category, we have observer, strategy, command, state, chain of result, responsibility, and visitor design pattern. There are many more other design patterns also, but these are the most popular ones. Now, before learning these types of design patterns, we must understand the categories of the design pattern: the creational, structural, and behavioral. What are creational design patterns? Creational design patterns are design patterns that deals with object creation mechanism. Now, object creation of a class is so simple like this. Yes, what is the problem here? The reason is the problem is in large or enterprise big applications. If you want to change this class from cat to dog, then you have to change it everywhere, wherever you have used it, right? And then it will be a testing issue. You have to retest all the classes like pet class this. Okay, so that's why writing code like this can be problem in future when you will try to whenever you will try to enhance your application. Okay, therefore we have design patterns like factory, method, builder, abstract factory, and singleton, which can optimize the object creation technique for the applications. Okay, what are structural design patterns? Structural design pattern is used to manage the structure of classes and interfaces, to manage the relationship between the classes. Okay, what is the meaning of relationship here? Let's try with the help of adapter pattern, which is a structural design pattern only. Suppose you have an application or software which is producing three outputs. Okay, and there is one other application which is taking only two inputs. Now, how you will connect these two applications? How you will connect the relationship? It is three output which is taking two inputs. Now here the answer is you will create an application in between them which will take three outputs, and it will give two, and it will produce two outputs, which will take three inputs of first application, and then it will produce two outputs for second application. Now you see these applications are well connected with each other. So that is adapter pattern, and that is like you are creating the structure so that a relationship between the classes. Now here is I took the example of application, but the same we can do with the classes also. Similarly, like adapter, we have decorator, facade, proxy design pattern, which are also like the structural design patterns also. I hope now you understand what is a structural design pattern. What are behavioral design patterns? This is the third category of the design patterns. The definition is behavioral design patterns are the way to communicate between the classes and the objects. So you have to choose the best way to communicate between classes and objects. Okay. For example, let's take example of a strategy pattern, which is also a kind of behavioral design pattern. In a strategy pattern, we can choose the best strategy at runtime for doing any operation. Here below you can see this flow. We can select here the best strategy out of quick sort, insertion sort, or merge sort to sort the list at the runtime. And here are the behavioral design patterns: observer, strategy, command, state, chain of responsibility, and visitor design patterns. So basically, in short, how to communicate between the classes, that for that you can choose one design pattern which will give you the options at the runtime. So that is called behavioral design patterns. What is singleton design pattern? This is a very important question. The definition is the singleton design pattern is a creational design pattern that ensures a class has only one instance of it. Only one instance. Meaning until the application is running, only one object or instance of the class will be used. Multiple objects will not be created of the same class. And then the same object will be shared by the multiple requests also. Okay, so normally we have class like this with method inside it, right? Then we create the object of the class like this and then call the method from the object, right? It's the traditional way. In our applications, wherever we need this method, we will call at multiple places in multiple requests. We create the object of the class multiple places then. But in singleton pattern, we have to create the object only once and then we have to use it at multiple places. This is how we are going to create the object of the singleton class via this getInstance method. Okay, now this code is implementing singleton class and it has 4 steps which I am going to explain. First step is declare class as sealed to prevent any further inheritance. Now if some other class will inherit this singleton class, then it will violate that singleton design pattern. So that's why we are putting sealed here, so that any other class should not inherit it. Second step is declare a static instance of this class, because only static instance you can use inside static method getInstance. Okay, so like if you will not put it static here, then inside getInstance method you getting this if instance equal to null, that instance will show you the compile time error. You can try it, it will not allow otherwise. Third step is to create a private constructor so that no one can create the object of this singleton class. So no object we need of this singleton class, that's why private constructor. Now sealed will not let anyone to inherit from this class, and private constructor will not allow the object creation of this class. Okay, that is good for singleton. And the last step is to create a method, the getInstance method, which will check whether the instance is null. If yes, it is null, then it will create the new instance, and if not null, then it will return the same instance which is already created by which is already created at first time. This is the way we will use same instance again and again for multiple requests, and this is the purpose of the singleton design pattern. How to make this singleton pattern thread safe? Now let's see what is thread safe and how we can make the pattern thread safe. This is the normal singleton pattern we already discussed in previous question. Okay, now suppose we have a multi-threaded application in which we are working, and now here 2 different threads reach here at the same time at this position if instance equal to null. Then both these threads T1 and T2 will check this condition here, and for both threads it will be null, right? Then both will enter inside this create new instance, which means now they will create two instances, which is the violation of the singleton pattern. So now we have to make our singleton pattern thread safe, so that it is not allowed. Okay, this is not good that these 2 threads are creating 2 instances at the same point of time. Now for that, first we will create a read-only object padlock like this, and then we will apply this lock method over this if condition. This lock will allow only one thread T1 at a time inside it. So okay, so this lock it will not allow both the T1 and T2 get inside at the same point of time, and it will let the other thread T2 to wait. So when T1 will do his job, will create the instance and come out of this lock method, then instance is already created, right? And then for the second thread T2, when it will go inside and it will check this null condition, it will fail, because the instance is already created by T1, right? And it will return the same instance from here. So this is how now our application is like thread safe. Our singleton pattern is like thread safe. So basically the one word answer is we have to use the lock to make our singleton pattern as thread safe. Okay. What is factory pattern? Why to use factory pattern? The first point you should know about factory pattern is the factory pattern is a creational design pattern and manages object creation. Okay. Now I will show you the example first without factory pattern and what is the problem there, and then I will show you how to implement factory design pattern and resolve that problem. Okay. See this code. Here we have the concrete classes Java and .NET with concrete methods. Java get framework written Spring Boot and .NET get framework method written .NET Core. Now we will use these method in a very normal way like this. See, this is the client code, and inside the main method we are creating the object of Java class and then calling the method and printing the value, and output will be Java Spring Boot. Same way we are creating the object of .NET class and final output will be .NET Core. Very traditional approach, nothing important here. Now here we have two problems with this approach. First is a lot of new keywords are here. See, new Java, then new .NET, right? And the second in a big application, if we have 50 technologies like Node, PHP, etc., then you will be having 50 new keywords here, which will not look good. Okay. Second problem is inside the client code, client will know all the concrete classes names. Concrete means these are the actual classes like Java and .NET, right? So for some project, this is a security issue because they do not want to expose the actual classes name in their client code. Okay. So these are the two problems, and now we will solve them with the help of factory design pattern. And for that, we have three types of factory design patterns. First is simple factory, then we have factory method, and the last we have abstract factory design pattern. In this question, we will use the simple factory pattern, and if you will know then only you can understand the abstract factory and factory method. Okay. So in upcoming question, we will explain factory method and abstract factory. Now here in simple factory, we have an interface iTech with a method get framework. Okay. Then two concrete classes, Java and .NET, which implement the iTech interface and provide their implementation of the get framework like this. Then we have a simple factory class tech factory with a method create tech that takes a string parameter tech type. And this method returns an instance of the corresponding Java or .NET object that implements the iTech interface, right? So if Java class is inherited from iTech, then it can return iTech interface. At last in the client code, we created an instance of this tech factory. So this is the factory class, okay, this tech factory. So why we are calling it factory? Because it will now create all the objects. It will this main method or the client code will not create the class objects. So that's why this is factory, because it is a factory for creating the objects. So see, inside the client code, we created an instance of the tech factory first and use it to create instance of Java and .NET by calling this create tech method with this appropriate tech type, whatever it is. Finally, in the output, the respective framework information get framework method, your output will be there. So your problem is solved. There are no new keywords in this client code right now. And second, we are not using even the concrete classes name here. See, no Java and I mean yes, we are using this Java and .NET strings here, but you can change this strings parameters strings, right, and make them something like J string or which are not related to Java name. Okay, so one caution here in factory design pattern, and that is it is not good for small projects. Okay, you can see how many lines of codes are here and it needs lots of planning, right? So it's good for big projects which are really big. then it will be good, but not for small projects. Finally, now we will conclude the definition. Factory pattern provides an interface or abstract class for creating the objects, but lets the subclasses decide which class to instantiate. Okay, so interface, one tech factory we have to create, and here instead of iTech interface, you can also see we have this iTech interface. You can also use here some abstract class, okay, with abstract method. Now this definition is slightly complex, so even you can make it more simpler, and you can say, in simple factory pattern, one factory class, here tech factory is that class, is responsible for creating all the objects for its derived or subclasses. Okay, great. I think now you know some basics of factory design pattern, and also you know what is simple factory design pattern, right? How to implement factory method pattern? Alright, as I said, we have three types of factory design patterns. Simple factory, I already explained, and here is the way we did simple factory, implemented simple factory in previous question. But the truth is, simple factory is not considered as a good factory design pattern. The reason is because simple factory provides a single factory class, here it is tech factory, okay, that created all the objects, while the factory method pattern uses inheritance and polymorphism, so it provides more flexibility and extensibility as comparison to simple factory. So factory method is the ideal design pattern, not the simple factory. Now I will show you how the factory method design pattern using inheritance and polymorphism. Okay, all right. Here first, these product interface and these two concrete product classes are same as that of simple factory pattern. This code is same. Okay, now instead of tech factory, we will create one abstract class creator with abstract method create tech. Okay, then two more concrete creator classes will be there, Java creator and .NET creator, which are inherited from this above creator class. Okay, the good thing is, as comparison to simple factory, we are not matching the strings. You remember, we are comparing the strings there in the simple factory, and that is not a very good way, right? Then at last, and also we are using inheritance first thing, like we are using this creator which is inherited in Java creator, and also we are using polymorphism like this override, right? This is a polymorphism way only. And at last, in the main method, we create instance of the Java creator and .NET creator classes, something like this, and use them to create the Java and .NET objects through the create tech method of the creator class. We then call this a get framework method on this object to show the output. So all is set here. Here you can see how inside the creator class, this create tech is the factory method. That's why, and how we implement this factory method create tech inside the concrete creator classes here. That's why this design pattern because is called factory method design pattern. Okay, because we implemented factory methods here. And here is the same design if I will show you the same design implementation in like flow. So here it is, and which you have seen in most articles and books, I think. Now the point is, from interview point of view, I understand this whole thing is not easy to remember. Okay, it is not even possible. Yes, when you want to implement it, you can refer something and then you can implement it. So, but you cannot explain it very easily. Yes. So, but you can remember some points from the list I am going to share about simple factory and factory method design patterns, which you can share with anyone, and I think they are enough. So here is the first point. The factory pattern is a creational design pattern which manages object creation. You know it, right? Second point is, factory pattern provides an interface or abstract class for creating object, but lets the subclasses decide which class to instantiate. So one class is there for creating objects, some kind factory class, but the subclasses will decide that which object they want to create, that decided by them. Then the third point is, in simple factory pattern, one factory class is responsible for creating all the objects for its derived or subclass. Very easy point, you can remember, right? And the next point is, simple factory pattern provides a single factory class that created the objects, while the factory method pattern uses inheritance and polymorphism to provide more flexible way of it. Okay, so these are 4 points which I think enough to know and which you can explain. Great. I think you did a great job in understanding this factory pattern now. What is abstract factory pattern? This is the third type of the factory design pattern. Here I will not show you the code here because it's too much of code and it's too complex, okay? But rather I will show you the basic idea of factory abstract factory, which you will easily understand, okay? You will understand when to use it and what it is for, this factory abstract factory pattern. Now suppose here we have one big IT company which is hiring directly the Java and .NET candidates, okay? What it is doing, it is doing it by itself. They themselves hiring it, this company. No factory pattern will be followed. They are directly creating the objects, you can say. But now next time this company will hire one agency which will act as the interface. Okay, now this agency will do the job of hiring Java and .NET candidates. So what happened? The creating of the object is the responsibility of this agency now. And this is quite similar to the factory method pattern, or a bit similar to this simple factory also. So because the object creation process is delegated to this interface, this some other class in between, okay, right? So now there can be more complex scenarios. For example, the same IT company is hiring tech candidates through a tech agency because they are expert in that, and non-technical candidates through a non-technical agency because they are expert in that non-technical domain, okay? So this is like now the abstract factory method pattern. So you can see we have increased the complexity from the normal factory method, right? The definition of the abstract factory pattern is: the abstract factory pattern is a creational design pattern that provides an interfaces for creating related families of objects without specifying their concrete classes. Now here we know every factory design pattern will not in the client code they will never disclose the concrete classes names, okay? So that also same thing abstract factory also do. Now what is this related families of objects? Here you can see finance and accounts are related families. Why? Because they are non-technical, okay? And similarly this Java and .NET are also related families. So like this, so this will be the structure of your classes in your single application, okay? But here is one more short definition of it is abstract factory, which is my favorite, and that is: abstract factory pattern can be thought of as a factory of factories, okay? So there are factories and you have one more factory over it. So this is the basic idea about the abstract factory design pattern. This is the mock interview number 8. The topic of this mock interview is design patterns and solid principles. If you have more than 4 years of experience in .NET, then this topic is important for you. Let me show you the questions here. This is the list of the questions. Pause the video and go through each of these questions and try to answer them in your mind or in a notepad. There is no less important question here. I hope you are done with it, so let's move forward.